is question 46 of civil engineering paper of GATE 2017 forenoon session. It is proposed to drive H piles up to a depth of 7 meter at a construction site. The average surface area of the H pile is 3 meter square per meter length. The soil at the site is homogeneous sand having an effective frictional angle of 32 degree. The groundwater table is at a depth of 2 meter below the ground surface. The unit weight of the soil above and below the groundwater table are 16 kN per meter cube and 19 kN per meter cube respectively. Assume the earth pressure coefficient K is equal to 1 and the angle of wall friction delta equal to 23. The total axial frictional resistance mobilized on the pile against the driving is. So, in this question, a H pile is driven into the ground up to a depth of 7 meter. The properties of this soil is given. This is a homogeneous sand. The effective frictional angle is given as 32 degree and the groundwater table is present at a depth of 2 meter below the ground surface. The unit weight of soil above and below the groundwater table are given as 16 and 19 kN per meter cube respectively. And the earth pressure coefficient K is given as 1 and the angle of wall friction delta is also given as 23 degree. And the cross sectional area of this pile is also given. The average surface area of the H pile is given as 3 meter square per meter length and it is driven up to a depth of 7 meter. So, now we need to calculate the total axial frictional resistance. So, this question is from the topic of ultimate load capacity of pile. You may study about pile load capacity and various formula to find it in detail in lecture 39 Pile Foundation Geotechnical Engineering 2 Foundation Engineering by Professor Dilip Kumar by the IIT Kharagpur. So, we know that the pile load capacity is attributed by two components. The first one is skin frictional and the second one is called tip resistance or point resistance. So, in this question we need to calculate only the axial frictional resistance. So, the formula for this total frictional resistance on the pile is given as QF equal to Fs into S, where Fs is the frictional resistance and As is the total surface area of the pile. Further, the value of Fs is given by this equation K into sigma dash into tan delta, where K is the earth pressure coefficient and delta is the angle of wall friction and sigma dash is the average effective overburden pressure. So, to calculate the frictional resistance on this pile, first we need to calculate this sigma dash, that is average effective overburden pressure. So, for that we just find, so suppose this is the pile length up to 7 meter and there is a groundwater table present. So, this is groundwater table present at depth of 2 meter. So, this is 2 meter and this is 5 meter. And the unit weight of the soil above and below the groundwater table are given 16 and 19 kilonewton per meter cube. So, here gamma dry is given as 16 kilonewton per meter cube and here gamma saturated is given as 19 kilonewton per meter cube. Now, so draw the effective pressure on this pile. We will get first, suppose this is point A, this is point B, this is point C. So, for AB, if we calculate the effective stress diagram, so for AB we may write this sigma dash equal to gamma into Z, where gamma is the this unit weight 16. So, this will be 16. So, if we calculate at this point, so if we calculate sigma dash at A, so depth is 0, so this will be 0. So, here we will get 0 effective pressure. Now, sigma dash at B, so it will be unit weight is 16 into depth. So, here depth is 2 meter. So, here depth is 2 meter. So, it will be 32 kilonewton per meter square. So here we can say that this will be 32. This will be 32. Now, the line joining this point will be the straight line. Why? Because you may see this equation is a linear equation. Sigma dash is directly proportional to z. So it will be linear. So just so this will be your effective stress diagram. Now for BC sigma dash again gamma into z. So now sigma dash at B, sigma dash at B will be 16. So unit weight of soil into height, 16 into 2. So this will be 32 kilonewton per meter square. Now sigma dash at C. So it will be so sigma dash for BC we may write gamma 1 into Z1 plus gamma 2 into Z2. So gamma 1 Z1 is corresponding to this layer AB, and gamma 2 Z2 is corresponding to this portion BC. So sigma dash at C will be 16 into 2 plus this is 19. So saturated unit weight is 19. So the submerged unit weight will be 19 minus 9.81 into depth 5. So after calculating this, we will get this one as 77.95 kilonewton per meter square. So here we will get the effective stress. We will get this one as 77.95. Now this is 32 and this is height 5 meter and this is 2 meter. Now since in this equation we need to calculate the sigma average. So for portion AB, we may write this frictional resistance Fs. We may write this frictional resistance Fs as this one, K into sigma dash, K into sigma dash into tan delta. So this is the frictional resistance, and if we find the total frictional resistance for portion AB, so we need to multiply this Fs with the surface area of AB. So it will be K into sigma dash into tan delta into surface area of AB. Now putting all this equation, so we have the value of earth pressure coefficient K as 1, and this is the average effective stress. So average will be from at A, this is 0, so 0 plus 32 by 2 into 0 plus 32 by 2, this will be average into tan del. So here the value of delta is given as 23 degree, tan 23 degree into surface area up to depth of AB. So here in this question the surface area is given as 3 meter square per meter length. So for AB we may write the surface area is 3 meter square per meter length into height 2 meter. So now after calculating this, we will get this total frictional resistance QF as 40.75 kilonewton. Now similarly for portion BC, for lower portion that is below the groundwater table, the QF of BC will be, K into sigma dash into tan delta into surface area for portion BC. So the value of K is given as 1, earth pressure coefficient is given in the question 1, and this is average effective overburden pressure. So average effective overburden pressure will be 32 plus 77.95 by 2. So this will be 32 plus 77.95 by 2. So this will give you the average value of effective overburden pressure. Now into tan 23 degree into surface area. So surface area is 3 meter square per meter length into total length is 5 meter. So this will be surface area. Now when we simplify it, we will get the value of this one as 350.03 kilo Newton. So this is the total frictional resistance for portion BC. So now the total frictional resistance on the pile will be QF for AB plus QF for BC, which is, so QF for AB is 40.75 and QF for BC is 350.03. So which will be equal to, if we add it, we will get this one 390.78 kilo Newton. So here we got the total frictional resistance on the pile is 390.78 kilo Newton. So here we can say this one is 390.78 kilo Newton. So the total axial frictional resistance will be 390.8 kilo Newton. So 390.8 is the correct answer for this question. Thank you.